Hello. We're going to do a little bit of practice with solving a system of equations by elimination. And we're going to add one more little step. This is the type of problem we have been solving. I know that this is a good problem to solve using elimination because they're both written in standard form. Elimination is an awesome strategy when the x's, the y's, and the constants, the numbers are all lined up. We're able to either add or subtract the entire equations, eliminating one of the letters. And this only works when we have one of the variables having matching or opposite coefficients. If the coefficients are the same number, we subtract the equations. If they're opposite, like 2 and -2, we would add the two equations here in order to solve for the missing variables. So this works again, it's super fast when the coefficients are opposite like this. If we look at this example, this one's a little bit different. If I look at it, neither one of these have matching coefficients, right? The x's don't match and the y's don't match. And so when we have a situation like this, we have to change the equation. So what we do is we're going to change this top equation so that the coefficient of x, I'll pick x, you could pick either one, matches. So we are going to multiply this entire equation by 3. Multiplying this entire equation by 3, we kind of imagine doing the crazy distributive property. We get 3x plus 3y is equal to 6. 3 times x is 3x. 3 times y is 3y. 3 times 2 is 6. So my first equation transformed to this by multiplying the entire thing by 3. 3x plus 4y is equal to 15. I just copy this one down. Now I'm able to solve these because my x's are matching. Okay, now I'm going to add these equations so that my x's cancel. By adding them, I get 7y and 21. To solve for y then, I divide by 7 and y equals 3. So we're halfway done solving this system. After we do the multiplying by 3, if you notice, all the work is the same. So there's just one additional step you have to do, and that's to get rid of to make sure that one of the letters variables has matching coefficients. All right, then we pick an equation to plug this into. I'm going to pick the first one because it has no coefficients. It's going to be a little bit simpler. I'm going to plug in y. Y is 3. Take away 3 from both sides, x equals -1. So my ordered pair is -1, 3. All right, let's just get started on this other example. If you look here, my x's are lined up, my y's are lined up, and my constants are lined up. So this is a good candidate for using substitution. If I want to get rid of the y's, if I want the y's to eliminate, we have to think, what am I going to multiply this entire equation by so that the coefficients are the same? In this case, we would multiply the entire thing by 2. So we're going to kind of distribute this out. 6 times 2 is 12x. 2 times y is 2y. 39 times 2 is -78. So this equation transformed to this. And I just copy down the other one. And now I have my two equations. Now I would have to decide if I add or subtract them. In this case, I'm going to subtract them so that these variables cancel. I'm going to stop here because I'm going to run out of time. Bye.